Okay, so in this question, we were looking at a recording of a basketball team. They recorded the number of points that each player scored and the number of shots they took. Okay, so the x-axis, how many of you plotted number of shots on the x-axis? Okay, and then based on how many shots they took, then we looked at how many points they got. So points should have been on the y-axis. It was the dependent variable because it's dependent on a shot. You can't get a point without a shot. Good. Okay, so this would be a strong correlation and positive. Good. As the number of shots increased, so as the team took more shots, what happened? They got more points. So the more shots they took, the greater the chance of them getting a point. Okay, so we wanted to know if they had 40 shots, how many points did they get? Yep. 65. Okay, so we'll look at the graph here. Now we want to find where 40 shots is, and you might get a little bit different. Your number might be a little bit different depending on how you drew your line of best fit. You might be off by a couple points, okay? It's not wrong. It depends where you draw your line. As long as your line is drawn close to the points, then you should get around the same answer. So what did 9? Okay, so according to this graph, this point is located at 40 and 69. So if they took 40 shots, they got around 69 points. Right. This information we had to interpolate because it was taken from information that was known in between our points that were plotted, okay? To read where 90 shots, so this point here, 90, and we needed to extend our graph here, okay? So just label the points. Where is that point located? 90 and what? 90 and 150. Okay, so if they took 90 shots, then they would have received 150 points. Was that point in between known values, or did we have to extend the graph? Did we have to go beyond it? We had to extend it, so we had to actually extrapolate, okay? Okay, so for 80 points, this point is located at, you want to see where the point hits the line because we're using this line to gather information, right? To make predictions. And this was just above, a little above 130, so let's say 132, okay? Okay, so now that we've drawn our line of best fit that you can see here, we need to come up with an equation of this line. Okay, and we know how to come up with an equation of a line in slope-intercept form. What is an equation of a line in slope-intercept form? How's it written? Y equals mx plus b. So we want to know what the equation of this line is, okay? And we've done this before. What are the two pieces of information you need to plug in to find the equation of a line? What do I need to replace? Okay, good. We need to find the slope of the line, and we need to find the y-intercept. Okay, so everyone has a line. So you're looking for 2 points, 2 coordinates that are directly on the line. So I wouldn't choose, look here for a sec, I wouldn't choose this one because it's not on my line, right? I want to just find 2 points that are easy to read. So for me, I would probably choose this point here because it's very easy to read this coordinate. This point is located at 60, 100, so it's really easy to read that point. It's not a decimal number. And maybe, let me see, okay, this one actually happens to be a point that was plotted, and it's directly on the line, and that one's easy to read. So I'll choose this one, 10, 20. Okay, so those are the 2 points I'm going to be working with. Okay, so now that I've chosen 2 points, is there any information that I can find in order to come up with my equation? Now that I have 2 coordinates, what can we find when we are given 2 coordinates? What's the first thing we can find? We can find the slope. Remember, we're trying to come up with an equation of the line. We need to know the m and the b. So now that I have 2 coordinates, I can find the slope of my line. Okay, so everyone find the slope of your own line. I'll call this 1 and 2. So y2 minus y1 over x2 minus x1. So that's 80 over 50, and I want you to write your answer in lowest term. My slope is equal to 8 over 5. Okay, that's the slope of my line. Okay, so now that I found the slope, what do you think the next step would be? Yep. Finding the y-intercept, okay? So how do we find the y-intercept if we now know the slope? So I have to choose one of my coordinates. I can choose this x and y and replace my x and y, and I have to replace my m, and then I isolate for b. Does it matter which coordinate I choose? No, because they're both on the same line. So choose one of the coordinates that you were using to find your slope. So I'm just going to choose this coordinate, okay? Okay, so I'm going to use the information. I have my slope, I have my coordinate. I'm going to plug in y, so 20 equals, m is 8 over 5, and x is 10. Because my slope's a fraction, I'm going to write my x value as a fraction, so that would be 10 over 1, right? And then I have plus b. So don't forget, when you're multiplying fractions, we multiply the numerator times the numerator, and then we multiply the denominator by the other denominator. Okay, so I have 20 equals, 8 times 10 is 80, and 5 times 1 is 5, plus b. Okay, so now I need to isolate for b, so what do I have to do next? Okay, so I'm going to bring 80 over 5 to the other side. I'm subtracting it, so it becomes 20 minus 80 over 5 equals b. When we're subtracting fractions, what do you have to do? I have to find a common denominator. What's the common denominator between 1 and 5? 5. So I need to multiply this and this by 5. What's 20 times 5? I'm just going to do this over here. So it becomes 100 over 5 minus 80 over 5 is equal to b. What's 100? Take away 80. 20 over 5 equals b. What's 20 divided by 5? 4 is equal to b. So I found that my y-intercept was 4. Okay, let's go back and look at the graph and see if that makes sense. This is for my graph, okay? So now if you look at the line here, okay, here's the line. Does it look like it probably would hit the y-axis at around 4? So it's very reasonable, okay? My answer makes sense according to my graph. Okay, so now that I've figured out m and b, what is the equation of this line that was drawn? Let's put it all together. Y equals 8 over 5x plus b was 4, right? Plus 4. And that's the equation of my line. Now that we came up with an equation, I can actually use this equation to predict any information based on the information in the graph. So looking at shots and points. Okay, which variable, x or y, represented the number of shots? Which one was shots, x or y? X, okay? So if I say to you, okay, well, I want to know information that's beyond, like way beyond this graph. So let's say I want to know if somebody takes 200 shots, okay, so if x is equal to 200, can you tell me, based on this trend, how many points would they get? Can you do this now without using the graph? Yes. Because we have an equation. What are we going to do with this number 200? Substitute it for x, plug it in, and figure out your y value. Our y value is our points. Okay, so now you have an equation. You can use that equation to predict trends, predict information about this graph. Okay, so I want you to do that right now. If somebody took 200 shots, tell me how many points they would get according to this pattern. If they take 200 shots, so if x is 200, I want to know what y is equal to. So I'm plugging this in, plus 4, and I'm solving for y. So 8 times 200 is 1,600 divided by 5 plus 4. So I have 320 plus 4, so y equals 324. So that means another point on my line. If I were to extend this way beyond, I would plot a point at 200, 324, which means what? What does that mean? What's x? The shots. And what was y? So according to this pattern, if somebody took 200 shots, then we can predict that maybe they're going to get 324 points.
Made with Doodlecast Pro.